Hello, ma'am.
Good evening, sir. You can start, sir.
Hello, ma'am. Yeah, ma'am.
Why, sir?
Yes.
Good evening. Good evening.
Good evening, sir.
Yeah, ma'am.
I made you host, sir.
All right. Any clarification with the electrochemistry chapter? We're done with it yesterday, day before yesterday. So, any clarification? Did you try to practice any of the questions? Any clarification? Any doubt?
No, sir, no doubt.
No doubt. Others?
No doubt, sir. No doubts.
Okay. The next chapter, that is chemical kinetics. Chemical kinetics means movement. Now, chemical kinetics, what is this chemical kinetics? What do you learn in this chapter, chemical kinetics? Now, react not necessary always to be in one step. Reactions can be in more than one step. When the reaction is in more than one step, then we call those reactions as multi-step reactions. We can call those as multi-step reactions. Now, this chemical kinetics is a branch in physical chemistry which deals with the study of the rate of the reaction. Rate is otherwise called as speed of the reaction. It's also called as velocity of the reaction. So chemical kinetics is a branch in physical chemistry which deals with the study of rate of a reaction, velocity of a reaction, or the speed of a reaction. Not only it deals with the study of speed of reaction, but also it deals with the study of mechanism of the reaction. See, in multi-step reactions, there will be intermediate compound formed. How intermediate compounds are formed, what are the intermediate compound formed, how this intermediate compound react in the second step, all that, what we study will be called as mechanism. So chemical kinetics, as we defined, it is a branch in physical chemistry. Which deals with the study of rate as well as mechanism of the reaction. All right, did you follow?
Yes, sir.
Yeah. Kinetics is a branch in physical chemistry which deals with the study of rate of a reaction, speed of a reaction, as well as the mechanism of a reaction. Now, broadly classified, we have two types of reactions. One will be inorganic reactions, and the other one will be called as organic reactions. Inorganic reactions, the other one will be called as organic reactions. These inorganic reactions are also called as ionic reactions. Organic reactions are also called as molecular reactions. So broadly, reactions is classified or can be divided into two groups. One is inorganic reactions, the other one is organic reactions. In inorganic reactions, are also called as ionic reactions. Why they are called as ionic reactions is because the reaction takes place between ions. Reaction takes place between ions. Therefore, it's called as ionic reactions. Now, organic reactions are called as molecular reactions because the reaction takes place between molecules. These inorganic reactions are very fast reactions. It's also called as instantaneous reactions. Inorganic reactions are also called as very fast reactions, instantaneous reactions. Organic reactions are generally slow. Have you done salt analysis in your college, schools? Salt analysis, detection of elements, acid radical, basic radicals, have you done? Did you do it? Students, have you done acid radical, basic radical analysis? Yes or no? Are you people there? Yes, you have done. Now, what is the confirmatory test for sulfate radical? Can anyone tell me what's the confirmatory test for sulfate radical? We take a sulfate radical solution, and to this we add barium chloride. When we add barium chloride, we get a white precipitate of barium sulfate. And this white precipitate which is formed is very fast. In a fraction of a second, we get white precipitate. As and when barium chloride comes into contact with sulfate radical, what happens? A white precipitate of barium sulfate is formed. So these kind of reactions are very, very fast reaction, instantaneous reactions. So for instantaneous reaction, it is difficult to find the rate of a reaction. For very, very fast reaction, we cannot find the rate of a reaction, difficult to find. Now coming to organic reactions, now for an example, if you take this molecule CH2 double bond CH2, this is called as ethene. Now when this ethene is allowed to react with hydrogen gas in the presence of nickel catalyst at 180 degrees Celsius, what happens is, now 180 degree, to achieve 180 degrees Celsius, the temperature required, the time required is more. Now at 180 degrees Celsius, what happens is the pi bonds will break. The hydrogen molecule also will undergo homolytic fission. One hydrogen will attack this carbon, the other hydrogen will attack this carbon. Therefore, the product what we get is, we get CH3, ethane we will get. Alkene is converted to alkane. Now for this reaction, the time is required to break the old bond and time is required to form new bond. Generally, organic reactions are slow. Organic reactions are also called as molecular reactions. Now, we can determine the rate of a reaction for a molecular reaction or a reaction which is slow. Now, this is with introduction to the chapter called as chemical kinetics. What is this chemical kinetics? Chemical kinetics is a branch in physical chemistry which deals with study of rate of a reaction as well as mechanism of reactions. Two types of reaction broadly: inorganic reactions. These inorganic reactions are also called as ionic reactions because the reaction takes place between ions. They are very, very fast reactions. Since they are very fast reactions, they are called as instantaneous reaction. Next, we have molecular reaction. These molecular reactions are reactions which are taking place between the molecules. And in molecular reactions, we require time to break the old bonds and we require time to form a new bond. Therefore, these molecular reactions are generally slow. Now, as per the syllabus, we have types of chemical reaction. On the basis of reaction rates, on the basis of reaction rates, on the basis of speed of the reaction, chemical reactions are classified into three types. On the basis of the speed, the chemical reactions are classified into three. One is very fast reaction, or it's called as instantaneous reaction. Very, very fast reactions are called as instantaneous reactions. These reactions occur at very fast rate. These reactions occur at very generally, they involve ionic species. I explained already. And this is known as ionic reactions. So inorganic reactions are very fast reactions or reactions which takes place in the between ions will be called as ionic reactions. And the reactions are very, very fast. For very, very fast reactions, it is almost impossible to determine the rate of a reaction. It will not be possible for us to determine the rate of a reaction because rate of a reaction takes place a fraction of a second, a blink of an eye, reaction takes place. Therefore, reaction is very fast. We cannot determine the speed. Example, I gave you one example. I wrote sulfate radical. Likewise, we have the reaction between silver nitrate and sodium chloride. So what happens is sodium and nitrate will get eliminated. Sodium nitrate. The silver and chlorine gets bonded as silver chloride, a white precipitate. It's called as precipitation reaction. A reaction in which precipitate is formed is called as precipitation reaction. Now, acid and a base reacts to form salt and water. You would have done titrations in your college or school, okay, as acid-base titration. So this neutralization reaction is also very fast reaction, very, very fast reaction, instantaneous reaction. We cannot find the rate of a reaction. All right. The second type of reaction, what we have to learn, is called as moderate reaction. One is very, very fast reaction. The other reaction is a moderate reaction. Okay, moderate reaction means the reaction is neither slow nor very fast. Those kind of reactions are called as moderate reactions. These reactions proceed with measurable rate. We can measure the rate of a reaction. We can measure the speed of a reaction. That is why they say moderate reaction. These reactions proceed with a measurable rate at normal temperature, and it is these reactions are studied in chemical kinetics. So in chemical kinetics, we talk about moderate reactions. In moderate reactions, we can measure the rate of a reaction. Mostly these reactions are molecular in nature. These reactions are what? Molecular in nature. Moderate reactions are molecular in nature. For an example, decomposition of hydrogen peroxide. This hydrogen peroxide, if you leave it open for some time, it will decompose to form water and oxygen. Likewise, nitrogen pentoxide, it will also decompose to form nitrogen tetroxide, giving you oxygen. These two reactions, decomposition reactions, are generally this moderate reaction. Moderate reaction. For moderate reaction, we can measure the rate of the reaction. Now, the third is very slow reactions. These reactions are extremely slow and take months together and show any measurable change, any measurable change. Now, for an example, they've given the rusting of iron. Rusting of iron is a very slow process. Iron get rusted in months together, very slow process. Likewise, hydrogen and oxygen will react at room temperature to form water. It is possible, but it is possible at a very, very, very slow pace. Therefore, these kind of reactions are called as very, very slow reactions. Now, based on the speed, reactions are classified into three. What are those? They're classified into instantaneous reaction, very fast reaction. For a very fast reaction, it is impossible to measure the rate. We cannot measure the rate because it's very, very fast reaction. The second is moderate reaction. This moderate speed reaction, we can measure the rate of reaction, right? And generally, molecular reactions are moderate reactions. And the third one, what we have is very, very slow reactions. This very slow reaction takes place in months. Reaction takes place months together. And to show a measurable change, they are called as very, very slow reaction. An example is rusting of iron. We will learn rusting of iron. Oh, I should have taught you rusting of iron. Remind me tomorrow when class I will start with the rusting of iron. Electrochemistry, I should have taught it. I forgot. Now I'm remembering. All right, students, are you there? So far, clear?
Yes, sir.
Yes, sir.
Yeah. Now coming to important concept you have to understand. All right. Now we have to learn what is rate of a reaction. In order to learn rate of a reaction, we will try to plot a graph. This is concentration as a function of temperature. Concentration as a function of temperature. At time, not temperature, sorry, time. Concentration as a function of time. Now tell me, at time t is equal to 0, what will be the concentration of the reactant? What will be the concentration of the reactant? At time t is equal to 0, the concentration of the reactant will be maximum. Yes or no? Now, if I consider a reaction A giving you product, the concentration of A at time t is equal to 0 will be maximum because no reaction has taken place. Therefore, the concentration of the reactant will be maximum. So I'll mark this as the initial concentration of the reactant. As time goes, what happens? Products are formed. When products are formed, it means concentration of the reactant is what? Decreasing. Now, as time goes, what happens? The concentration of the reactant goes on decreasing. Followed with this?
Yes, sir.
This is with respect to reactant. Now, what happened? At time t is equal to 0, the concentration of the product is 0. No product is formed. As time proceeds, what happens? The concentration of the product increases. So what happens? Initially, at time t is equal to 0, the concentration of the product is 0. As time proceeds, what happens? Concentration of the product increases. This graph shows you the increase in product with respect to time. Now, what we're talking about is, we're talking about rate of a reaction. How do you define rate of a reaction? Rate of a reaction is defined as the ratio of change in concentration with respect to time. How do you define rate of a reaction? Rate of a reaction is defined as change in concentration with respect to time. When I say change in concentration, there is a change in concentration of the reactant as well as there's a change in concentration of the product. Concentration of the reactant decreases, concentration of the product increases. Therefore, rate of a reaction, rate is represented by small letter r. Rate of a reaction with respect to reactant, specifically as, since the concentration of the reactant decreases, we can write decrease in concentration of the reactant with respect to time. Now, how do I define rate of reaction with respect to reactant? It is decrease in concentration of the reactant. In the graph, you can see the concentration of the reactant decreases as the time proceeds. Likewise, with respect to product, how do I define rate of a reaction? I'll write here. With respect to product, rate of a reaction with respect to product. With respect to product, we can write what's happening to the concentration of the product. Increases. Increase in concentration of the product with respect to time. So increase in concentration of reactant with respect to concentration of the product with respect to time is also defined as rate of reaction with respect to product. Followed with this, what is rate of reaction? Yes?
Yes, sir.
Yes.
Yes, sir.
Now, this rate of a reaction is represented as plus or minus dx by dt. This rate of a reaction is represented as plus or minus dx by dt or plus or minus dc by dt. Now, what is this dc and dx? Dx is nothing but change in concentration, or dc is change in concentration, and dt is nothing but change in time. Now, what does this plus and minus signifies? Plus signifies increase in concentration of the product with respect to time, and minus sign signifies decrease in concentration of the reactant with respect to time. Did you understand this? So this is called as rate equation. Plus or minus dx by dt or plus or minus dc by dt. This is called as what equation? Rate equation. This is called as what equation? Rate equation. Followed?
Yes, sir.
Yeah. Now, if you have followed with this, now what will be the unit for rate of a reaction? The unit for rate of a reaction will be concentration. Generally, it is expressed in molarity, mole per liter, and time is in terms of seconds. Therefore, the unit for rate of a reaction is mole per liter per second. Mole per liter per second. This is the unit for rate of a reaction. They can ask you, what is the unit for rate of a reaction? The unit for rate of a reaction is mole per liter per second. Because the concentration is expressed in terms of what? Molarity, and time is expressed in seconds. Therefore, the unit for rate of a reaction is mole per liter per second. Followed? Followed?
Yes,
Yes, sir.
yes, sir.
See, there is a lot of rain happening. All right. So the internet connection, I don't know how stable it will be. All right. We'll have to continue, but a few minutes. Let's see. Now, I hope that you understood the definition of rate of a reaction, unit for rate of a reaction, what is plus and minus signifies in the rate of a reaction, all that. All right. Now, just we'll consider again a point with respect to rate of a reaction based on the graph. Now, based on the graph, you can draw a slope. You can draw a slope. Now, what is a tangent? A tangent is a straight line which touches one point. So now this will be a slope. So this is nothing but change in concentration. This is nothing but change in time. The slope here will be what? dx by or dc by dt here. And this will have a negative value. It's a negative slope. And likewise, here also you can draw a tangent and you can get a slope here also. We can draw, this is dx by dt. I think in the slope of these graphs will give you the rate of a reaction. So graphically also we can find the rate of a reaction by drawing a tangent and drawing a slope. Slope will give you the rate of a reaction. Followed?
Yes, sir.
All this is the same what concept we learned. Anyways, we will understand. Now, concentration is generally expressed in terms of active mass, that is mole per liter. Concentration is okay. The rate is the unit for rate is mole per liter per second. We learned it here. Now, the rate measured over a long time interval is called as average rate, and the rate measured for an infinitesimally small time interval is called as instantaneous rate. So, if you measure the rate of a reaction for a long time interval, slow reaction, very slow reaction, long time interval, it is called as average rate. And if we measure the rate for an infinitesimally small time, instantaneous rate. Instantaneous rate is equal to average rate when time t is tending to 0. We'll learn about this if technically later. Now consider this for a reaction, A moles of A plus B moles of B giving you C moles of C and D moles of D. What is this A and B here? A and B are called as reactants and C and D are called as products. Now the small letter A is coefficient of reactant A, small letter B is coefficient of reactant B, small letter C coefficient of C, and small letter D is coefficient of the product D. Now the rate of disappearance of reactant. I told you as the reaction proceeds, the concentration of the reactant decreases, I told you. As the reaction proceeds, the concentration of the reactant decreases. Now the decrease in concentration of the reactant is mentioned as disappearance of reactant. All right. So decrease in concentration, our right word for that is to mention as disappearance of the reactant only. All right. Now, see, for a reaction, A moles of A plus B moles of B giving you C moles of C plus D moles of D, the rate of disappearance of reactant is negative. Since there is a disappearance of reactants, we represent it by what sign? Minus sign, negative. Minus D is change in the concentration of A divided by dt. Change in concentration with respect to time is called as rate. Decrease in concentration of the reactant with respect to time is called as rate of a reaction with respect to reactants. That is represented by what sign? Minus sign. This minus sign indicates there's a decrease in concentration. That is equal to rate of disappearance of A, speed of disappearance of A. Likewise, you can see here, B is also a reactant. Rate of disappearance of B with respect to time, or rate of decrease in concentration of B with respect to time is called as a rate of disappearance of B. Did you follow why is minus sign for A and B? Followed or not?
Followed, sir.
Yeah. Now, with respect to C and D, what is the C and D? C and D are products. C and D are products. Now, products are formed. So we give a heading, rate of formation of product. Since products are formed, it is positive. It is positive. So now with respect to the product, what is the rate Rate is defined as change in concentration of C with respect to time. It's called as rate of formation of C because C is a product. Likewise, change in concentration of D with respect to time, dt, that is nothing but rate of formation of D. Rate of formation of D. See, this is very important. This understanding is very important to work out the problems. Now we will understand this. Now this equation is written for, this relation is written for equation A moles of A plus B moles of B, giving you C moles of C and D moles of D. Now A and B, capital A and capital B are reactants, capital C and capital D are products, small letter A and B are coefficients of reactants, small letter C and D are coefficients of the products. Now, this is important. Please pay attention when I'm teaching you because problems will have to work based on this. If you don't understand this, problem working will be difficult. A certain type of problem working will be difficult. Now, in terms of stoichiometric coefficients, rate may be expressed as, now rate is expressed as dx by dt, change in concentration with respect to time. Now, with respect to the reactant A, it is minus change in concentration of A with respect to time. But here you have coefficient. This coefficient, when coefficient is 1, if you leave it like this, it's the same. But when you have other than 1 as a coefficient, then we have to divide that coefficient also. So therefore, it will be what? Minus 1 by A, dA by dt. Did you understand?
Yes, sir.
Now, similarly, rate of disappearance of A will be equal to rate of disappearance of B. For B, what will happen? Change in concentration of B with respect to time, but coefficient of B is small letter b. Therefore, it is minus 1 by B. Why it is minus? Because it's a reactant. That will be equal to, now C and D are products, formation, products are formed. Therefore, it's having a positive value. So change in concentration of C with respect to time, but the coefficient of the reactant C is C, therefore 1 by C. And that will be equal to change in concentration of D with respect to time, the coefficient of D, small letter d, therefore it's 1 by d. That is what it's been typed here. Same thing. I hope that you followed how to write this stoichiometry coefficient for a rate equation. You understood this?
Yes, sir.
Yes. Now, if you have understood this, we will try to write 1 or 2 relationships. For 1 or 2 reactions, we will try to write. Let's see, the first one we will write is, H2 plus I2 giving you 2HI. How do I write the rate equation for in terms of stoichiometric coefficient? Rate is defined as dx by dt. That will be equal to change in concentration of H2 divided by change in concentration of dt. Yes or no? Yes or no?
Yes, sir.
Any mistake? Any mistake? Anything which I have not written?
So minus.
Minus sign I should
So
write.
minus, sir.
Plus H2 is a reactant. Minus change in concentration of hydrogen with respect to time. That will be equal to minus change in concentration of iodine with respect to time. Minus, because it's a reactant. That will be equal to what? Plus change in concentration of HI with respect to time. What else I have to do? What is the coefficient of HI?
2, sir.
So what should I do? I should divide it by 2, 1 by 2, plus 1 by 2, change in concentration of HI into dt. Followed with this? The second example, I'm giving you the reverse of this. H2, 2HI giving you H2 and I2. What is the rate? Rate is dx by dt. That is equal to, now how will I write for this? Change in concentration of HI divided by HI divided by dt, but coefficient is 2. So therefore 1 by 2, and HI is a reactant. Therefore it will be minus 1 by 2 change in concentration of HI divided by dt. That will be equal to what? Change in concentration of hydrogen with respect to time. Coefficient is 1 and it's a product. Therefore, I write it as plus, or if I leave it without writing plus also, it doesn't matter. That will be equal to change in concentration of iodine with respect to time. So it's plus. Because hydrogen and iodine here, it is what? The product. Followed with this? One more we will write. Yeah, one more reaction we will write. N2 plus 3H2 giving you 2NH3. This is the reaction. How do I write the rate based on the stoichiometric coefficient? Rate is defined as change in concentration with respect to time. Now, specifically with respect to reactants, what will be? Minus change in concentration of nitrogen with respect to time. That is equal to minus change in concentration of hydrogen with respect to time. Since the coefficient of hydrogen is 3, I have to divide by 3. So 1 by 3 minus 1 by 3, change in concentration of hydrogen with respect to time. That is equal to plus 1 by 2, change in concentration of ammonia with respect to time. Did you follow? Students, did you get this?
Yes, sir.
Now, see here, the rate of a reaction is always positive. The speed, because reaction is proceeding, therefore, the rate of a reaction is always positive. The unit for chemical reaction, rate for chemical reaction decreases as the reaction proceeds. So initially, the rate of a reaction will be fast. After some time, the rate of a reaction becomes slow. Now, I gave you this already, the unit for rate of a reaction. Unit for rate of a reaction is mole per liter per second. So in general, they've given mole per liter per time. Concentration is in molarity, mole per liter, and time is in seconds normally we will take. So it can be in hours, months, minutes. So they've given in general mole per liter per time. Remember. Now for a gaseous, for a gaseous reactant or for a gaseous reaction, the unit is atmosphere per time. Because in terms of reaction which is in gaseous state, we will measure the pressure. We will not talk about concentration for a gaseous reactants. So when we talk about a gaseous reactant, we talk about pressure. The unit for pressure is atmosphere. Therefore, it's atmospheres per time. Now, and rate in atmosphere per time is equal to rate in mole per liter per time into RT. So this relation we will learn later. Rate in atmosphere time is equal to rate in mole per liter per time into RT. So PV is equal to RT. Based on that concept, this equation is written. This you don't have to worry. I want you to remember this. I want you to remember this. And also, I want you to remember how to write the rate equation for different reactants and products. Follow this. Students, did you understand so far?
Yes, sir.
Can we continue?
Yes, sir.
Yeah. Oh, there's a lot of space here, right? What's happening? Some of the questions we'll solve based on this, what we learned so far. When a chemical reaction takes place, during the course of the reaction, the rate of a reaction keeps on increasing with time, remains constant with time, keeps on decreasing with time, shows irregular trend with time. Tell me, I taught you this. When a chemical reaction takes place, during the course of the reaction, rate of a reaction, I told you initially the rate of a reaction will be what? More. After some time, the rate of a reaction, the speed of a reaction decreases, I told you. See, you should remember rate of a reaction is directly proportional to concentrations of the reactants. Concentration of the reactants. Now what happens? Initially, the concentration of the reactant will be maximum. Since the concentration of the reactant is maximum initially, the speed of the reaction will be more. But as the time proceeds, what happens? The concentration of the reactants decreases. Therefore, the reaction also decreases. Hence, maybe we can write a statement like this: as a reaction proceeds, concentration of the reactants decreases. Hence, the rate also keeps on decreasing. Hence, the rate also keeps on decreasing. So answer for this question is what? Option C, keeps on decreasing with time. I gave you the explanation. The rate of a reaction is directly proportional to concentration of the reactant. As reaction proceeds, what happens? The concentration of the reactant decreases. Therefore, what happens? Rate of reaction also decreases as time proceeds. Now, for a reaction, second question, for a reaction P plus Q giving you 2R plus S, which of the following statement is incorrect? Which of the following statement is incorrect? Rate of disappearance of P is equal to rate of appearance of S. You can see the coefficient of P is 1. The coefficient of S is also 1. Therefore, the rate of disappearance, at what speed P disappears, the same speed S appears. Therefore, this is correct. Now, the rate of disappearance of Q is equal to 2 into rate of appearance of R. Rate of disappearance of Q is equal to rate of disappearance of R. We'll make it, wait for a minute. The third option, rate of disappearance of P is equal to rate of disappearance of Q. Because coefficients are 1, the same speed at P disappear, the same speed Q also will disappear. This also is right. Now the fourth option, if you see, rate of disappearance of Q is equal to half into rate of appearance of R. This is also true. See here 2R and here it is what? Q. So rate of disappearance of Q is half the time for the appearance of R. Therefore, this is also true. The answer, the wrong option is this: rate of disappearance of Q is twice the rate of appearance. No, it is not twice. It is half the time appearance, because Q has coefficient 1 and R has coefficient 2. So speed at which Q disappears will be equal to half the speed at which the R appears. Therefore, the answer for this question is option B. They're asking which is incorrect, they've asked. The next question. Okay, this you should know. You will write very easily. For a reaction, N2 plus 3 H2 giving you 2 NH3, how are the rate of reaction expression interrelated with respect to change in concentration of hydrogen and ammonia? Hydrogen, what is that? It is a reactant. Therefore, it's minus change in concentration of hydrogen with respect to time. Since coefficient of hydrogen is 3, you have to write it as minus 1 by 3. That will be equal to ammonia as a product. Change in concentration of ammonia with respect to time. And the coefficient of ammonium is 2. Therefore, it's plus 1 by 2. Hence, the answer for this question is option A. It's written here. Option A, the same thing. So, students, are you following?
Yes, sir.
Now, oh, I didn't tell you about rate constant anyways. We'll see. Okay. Now, consider a reaction 2N2O4. It's a reversible reaction. 2N2O4 giving you 4NO2. If decrease in concentration of nitrogen tetroxide is equal to K and change in concentration of nitrogen dioxide is 4, is K prime, then what is the relation they're asking? To K prime or K dash? You can call this as prime or we call it as dash. That's fine. Now, for this particular reaction, how will you write the change in stoichiometry? Now, since N2O4 is a reactant, the concentration of the reactant has to decrease with respect to time. Therefore, we write it minus sign. And since the coefficient is 2, we write it as 1 by 2. And that will be equal to NO2 is formed. It's a product. So change in concentration of NO2 with respect to time, and it's a plus sign. and coefficient is 4, 1 by 4. This is the relation. What is that they've given? Now they've given change in concentration of nitrogen tetroxide with respect to time is K. So that means it is minus 1 by 2 into K. This value they've given as K. They've not talked about the coefficient, it's K. And here it is plus 1 by 4, and they've given change in concentration of NO2 with respect to time is what? K prime or K dash. Now how they are related? How they are related? Now you can simplify this. This will get twice and all that. So 2K will be equal to K prime. 2K will be equal to K prime. This minus sign you have to neglect. This minus sign indicates only decrease in concentration. All right. So the relation is what now? 2K is equal to K prime. So what's the answer for this? Or you can write K prime is equal to 2K either ways. Hence the answer for this question is option B. Option B. Did you follow?
Yes, sir.
Now for a reaction 2NH3 giving you N2 plus 3H2, if change in concentration of ammonia with respect to time is equal to K1, concentration of ammonia, and change in concentration of nitrogen with respect to time is K2 into concentration of it's nitrogen. This should be nitrogen. This should be nitrogen. This should be nitrogen N2. N2. And here it should be hydrogen. K3 is into hydrogen. Then the relation between K1, K2, and K3 is. Now they're given you the reaction 2NH3 giving you N2 plus 3H2. What's the stoichiometrical rate equation? It is minus 1 by 2 change in concentration of ammonia with respect to time, that is equal to plus change in concentration of nitrogen with respect to time, that is equal to 1 by 3 change in concentration of hydrogen with respect to time. This is the stoichiometrical rate equation. But what is given? They have given you change in concentration of ammonia with respect to time is what? K1 into ammonia. See, that means minus 1 by 2, or we'll just write the stoichiometry. Minus is a representation, that's all. Minus 1 by 2 into K1 ammonia. K1 ammonia. This will be equal to what? They have given K2 into ammonia. Ammonia is correct, man. This is ammonia only. This is ammonia only. So K2 into ammonia. This K2 into concentration of ammonia. And this will be what? 1 by 3 into K3 into concentration of ammonia. So on simplifying, you can take the ammonia will get cancelled. All right. So if you take the LCM and then simplify, we will get what is the LCM? 2 plus 1 plus 3, 6. If you take 6, 1 by 2 is what? 3. So it will be 3K1 will be equal to 6K2, and this will be equal to what? 2K3. I told you this is taken as LCM. Did you understand what I'm talking? Did you follow this?
Yes, sir.
Huh?
Yes,
Yes or
sir.
no? So dividing by the least is 2. So divide 3 by 2 is 1.5 K1 is equal to 3 K2 is equal to K3. So the answer for this question is option C. 1.5 K1 is equal to 3 K2 is equal to K3. All right. So this numerical will work possibly in the next class. We will work. Numericals will work in the next class. All right. Now, so far, is it clear? Dhanlakshmi, Ritika, did you follow something today?
Yes, sir.
Ajay?
Yes, sir.
Ajay, followed? Ma'am, I'll
Yes,
start
sir.
the class, ma'am. Hello, ma'am.
Yes, sir.
Start the class, ma'am.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye, bye, bye.